So now we will discuss about the free electrons theory. Okay, free electrons theory and band theory. So first we will discuss about the free electrons. Okay. So in this free electrons theory, is nothing but it's we have to study about the conduction, electrical conductivity or the conducting material based on we will study about it. Okay. So in this unit, what is free electrons? Free electrons theory. First we will discuss about what is free electrons. Any idea about what is free electron? Hmm? What is free electrons? What ma? Valence electrons. Okay. So free electrons is nothing but it's a valence electrons. Okay. It's nothing but it's a valence electron. Okay. So here the free electrons is nothing but it's a valence electron. It's a valence electron. Okay. So here in this free electrons is nothing but it is present in our considered conducting materials. Okay. So what is conducting material? The material is act as the conduction process. Okay. The material it act as the conduction process. That particular material is called as the conducting materials. Okay. So in this conducting materials, more how these type of the material this act as a conductions means this particular material is having the free electron due to the presence of free electrons nala and materials எல்லாமே வந்து it act as a conduction process னு சொல்றோம் ஓகேவா so normally வந்து we will divide it into three different types of material. One is the conducting material, another one is the semi-conducting material, last one is the insulator material. Okay, so conducting material is nothing but it acts as a conduction process, so it's called as a conducting. Semi-conducting material is nothing but it is the partially conducting, partially act as the insulator. Okay, so it having the both characters, and insulator it does not act as a conducting material. Okay, so here we will discuss about the free electrons. இப்போ வந்து நம்ம ஸ்டடி பண்ண போறது free electron. அப்போ free electrons ஓட play எங்க இருக்கும், அதோட act எங்க இருக்கும்னு பாத்தீங்கன்னா it's in conducting materials தான் இருக்கும். Okay, so for example we will take as the number of we will take as any one of the conducting material. It having the lot of electrons. Okay, a number of atoms இருக்கும், atoms உள்ள electrons இருக்கும். Okay, so in this electron is nothing but it is placed at the outermost orbital set. Okay, so here, so for example, this is our considered atom. In this atom, the center point la nucleus இருக்கும். Okay, and also it having some innermost orbit இருக்கும். And here some electrons is placed here, here some electrons is placed here, and here also some electrons is placed here. Okay, so but the outermost orbit இருக்கிற electrons எல்லாம் we call as the free electrons னு சொல்லுவோம், or we call it as the valence electrons னு we will call it here. Okay, தெரியுமா? Okay, so it is called as the valence electrons. Okay, so this our free electrons or this valence electron it ready to start conduction process. ஏன்னா இது வந்து இது எங்க பிளேஸ் ஆயிருக்கு, it is placed in our outermost orbital. Okay, so அப்ப நீ ஒரு field எங்க இருந்து நீ கொடுக்கும்போது one of our considered material when you apply some electrical field here, so that particular so this outermost electron first it ready to start for the conduction process னு சொல்றோம். Understood? Okay, so இதான் வந்து ஒரு free electrons ஓட ஒரு act. So this conducting material இன்னொன்னு சொன்னா it's a low resistivity material, நம்ம சொல்லலாம். Conducting material is nothing but it is a low resistivity material. ஏன்னா வந்து அந்த only conduction, it does not have any resistive flow of the current. Okay, so that's the reason it acts as a conducting material. Okay, so in this free electrons theory we will discuss about the three theories. One is the classical theory, another one is the quantum theory, and third one is the band theory. So classical is the macroscopic theory. Here also we will discuss about the free electrons only. Quantum is one of the microscopic theory. Adli nama free electrons பத்தி தான் நம்ம ஸ்டடி பண்ணோம். Last one is the band theory. Band theory la energy band gaps we will discuss here. Okay, so now we will discuss about some postulates of the free electrons theory. What are the postulates of free electron theory? So in this free electron theory we will discuss about some three postulates. Three postulates in the So the first postulate is nothing but we will take as any one of the conducting material. Here are the conducting material. For example, we will take as metal. Okay, so here in our considered metal when the field is equal to 0, field என்ன கொடுத்திருக்கோம் 0 கொடுத்துருக்கோம். ஓகேவா? So we will take it as one considered material. So here the field is nothing but it is equal to 0. There is no field. Okay? So here all the electrons or all the atoms are is placed in this considered material. எப்பவுமே ஒரு solid materialsல atoms எல்லாமே regular periodical arrangement தான் இருக்கும். One of the perfect solid material. Okay? அது ஈஸியா breakable இருந்துச்சுன்னா it's some random directions இருக்கும். One of the strongest material, one of the perfect solid materials, atoms of the electron atoms எல்லாமே it is arranged in periodical direction. Periodical pattern. Okay? Periodical pattern எப்படி இருக்கும்? So எப்படி நீ கிளாஸ் ரூம்ல ஆர்டரா இருக்கியோ அதே மாதிரி all the atoms எல்லாமே வந்து it is arranged in orderly. Line by line தான் வந்து it is present here அப்படின்னு சொல்றோம். ஓகேவா? So நம்ம லேப் டெஸ்ட் நம்ம ஃபோன் போடுவோம்ல அந்த லேப் டெஸ்ட் மாதிரி வந்து அது ஆர்டரா வந்து ஸ்பெசிஃபைடா இருக்கும். Okay? So here in this now when the field is equal to 0, we will take as one of the conducting material. All the electrons, all the electron, it is moving in random direction. Okay? All the electron, it is moving in random. எப்பவுமே field 0 ஆ இருந்துச்சுன்னா electrons does not having any energy. அதுக்கு energy இருக்காது. It is placed at the rest condition. Okay? Here also it does not having energy, but some energy இருக்கும் because வந்து it's a free electron. It ready to start moving. It ready to start moving for the conduction process. Ready ஆ இருக்குது. ஓகேவா? அது ஆக்டிவா தான் இருக்கு. So this when the without applying the field, all the electrons it is moving random direction. It is moving in random directions. Okay? So it getting some vibrations. So when அப்படியே long distance travel ஆகாது, it having some motions. Some random motions. It's getting some vibrations takes place in our considered free electrons. Okay? So due to the presence of vibrations, the collision processes takes place. Okay? So what type of the collision? The lattice elasticity and great gravity. Okay? And also in this free electrons, we should call as the kinetic theory of gases. It is called as the kinetic theory of gases. Why we call as a kinetic theory of gases? For example, we will take as one of the container. We will take as one container. In that particular container, number of we will fill some molecules, gas molecules, gas mixture of gases. Our gas fill பண்ணும்போது என்ன ஆகும்? அது dissolve ஆகுமா? It getting some dissolving condition. We will take as one of the container. For example, take some solutions. So when our complete dissolving conditions come, it look like a random motions. Okay? So we have to take it as one container. In that particular container, we will fill some gas molecules. So another mixture of the random motions of the molecules. Okay? But the molecules the kinetic energy random motion it having some kinetic energy and the potential energy okay? It getting some random motion. No? In this gas molecule in our container, it acts as a kinetic energy. It having some kinetic energy. So when each obey the kinetic theory of gases. Okay? So in the same way, we have considered conducting material having the number of electrons without applying the field. Without applying the field, all the electron it is moving in random direction. Okay? எல்லாமே electrons எல்லாமே random directions move ஆகறனால it look like a gas molecule present in the container. அப்படினு சொல்றோம். ஓகேவா? சோ இந்த மெட்டீரியலோட இருக்கிற free electrons ஓட random motion எப்படி இருக்குன்னு சொல்றோம்னா இந்த கண்டெய்னர்ல இருக்கிற gas molecule motions மாதிரி இருக்குது. So that's the reason this free electron without applying the field, this free electron is getting the random motion. It obey that the kinetic theory of gases. We will call this. Okay? So that is the second point. Okay? First point when the field is equal to 0, all the electrons are moving in the random direction. All the electrons it is moving in random directions. The second point, and also that's the reason the collision state are there in our so that's the reason lattice elasticity and form ஆகுது. Okay? Second point is nothing but it obey the kinetic theory of gases. அது வந்து உங்களுக்கு presence of field ல கொடுத்திருக்காங்க. அது வந்து நீங்க absence of the field ல தான் எழுதணும். But in your book they given that the presence of field ல கொடுத்திருக்காங்க. Absence of the field ல all the electrons it is moving in random direction. So that's the reason it obey that the kinetic theory of gases because it look like a gas molecules. அப்படின்னு சொல்றோம். Understood? Any doubt in this step? Any doubt? Okay. So the second point is when the field is not equal to 0. When the field is not equal to 0. Field is not equal to 0 and all the already it's having some periodical arrangement. Random field illanalu it having some energy, kinetic energy இருக்குதுங்க. So So when the field is not equal to 0, no, when we apply some field, okay. So when we apply some field, all the electrons or this nothing but it is moving in one of the particular direction. Okay, it is moving it is arranged orderly, order arranged item. So when we apply some electrical field, all the electrons is nothing but it is moving opposite or towards the field direction. So that's the reason here the current condition is produced. Okay, already it having some energy. நம்ம ஒரு ஃபீல்ட் கொடுக்கும்போது என்ன நடக்கும், எல்லா எலக்ட்ரான்ஸுமே வந்து ஒரே சைடுல ஆர்டரா அரேஞ்ச் ஆகி இட் இஸ் மூவிங் ஆப்போசிட் டு த ஃபீல்ட் டைரக்ஷன்ஸ் அப்படின்னு சொல்லிருக்காங்க. In some book they given for that to next page towards the field direction, towards or opposite the current condition is produced அப்படின்னு சொல்றோம். Understood? Understood in this? So it having that the three valid postulates points here. So due to the motion of the electron, if என்ன நடக்குது, electrons is getting some motion. Electrons என்ன நடக்குது, when we apply some electrical field, electron is getting some motion. Okay, electron வந்து என்ன, it is moving or moving towards or opposite to the field directions, no. Okay, so that's the reason இங்க ஒரு velocity produced ஆகுது. ஓகேவா, so motion of the electrons இருந்துச்சுன்னா velocity இருக்குமா இருக்காதா, when it's carrying velocity or not, இருக்கும். Okay, and also here we will call it as the drift velocity னு சொல்றோம். ஏன் இந்த drift velocity னு சொல்றோம்னா, because all the electrons it is moving in one of the particular direction. All the electrons moving in our considered particular direction. So அதான் இங்க சொல்லிருப்பாங்க, average velocity acquired by the free electron in moving in our particular direction due to the presence of the applied electrical field. That is called as a drift velocity னு சொல்லிருக்கோம். See in the book. Okay, average velocity acquired by the free electron moving in a particular directions. Particular directions na ஒரே directions la order move ஆகுது due to the presence of the electrical field. That is called as the, what is that, drift velocity நம்ம சொல்றோம். Okay, understood? So next step la என்ன சொல்லிருக்காங்க, mobility. So mobility, so average velocity நம்ம என்னன்னு சொல்லலாம். So here due to the presence of the the electrons moving in the particular direction. So the mobility term is nothing but the drift velocity. The drift velocity present due to the presence of free electron per unit volume, per unit applied electrical field. So mobility term எப்படி சொல்லலாம்? So the mobility is nothing but it is represented by mu is equal to Vd divided by V. Okay. So the drift velocity acquired by the free electron per unit electrical field. So that is called as the mobility. Mobility வந்து நம்ம motion னு சொல்லலாம். ஒரு moving particles இல்லனா motion of the electrons னு சொன்னா கூட நம்ம mobility act பண்ணுதுன்னு சொல்லுவோம். ஓகேவா? So here mobility is nothing but it's the drift velocity per unit volume is called as, per unit electrical field is called as the mobility னு சொல்றோம். Understood? Any doubt in this steps? Mobility na drift velocity here. Is there any doubts, ma? Okay, ma. Clear, understood? Okay. So now we will go further the expression for the electrical conductivity in terms of the mobility. Okay, ma. So இது வந்து in this unit la two expressions இருக்கு. Electrical conductivity la two expressions இருக்கு. One is the expression for the electrical conductivity. Second one is the expression for the electrical conductivity in terms of the mobility. Understood? So you see in our expression here. So here I will consider, listen now. Everyone listen. I will consider one of our considered rod. Okay, ma? So this is our considered rod, and this particular rod is nothing but it is the conducting material. It's the conducting material, and then I connected this power supply here. So in this considered rod, its length is nothing but that is L. Its length is what is that? L here, and also the area is nothing but so this portion, this is the area of the cross section. So inside of this material, it having a number of electrons. நிறைய electrons இருக்கும் இல்ல. So that's the reason that is represented by small n. That is represented by small n. Okay. So now here we should calculate about the total number of electrons. So if நம்ம என்ன பண்றோம், when we apply some field direction. So this is a field direction. So when we apply some electrical field here, all the electrons are moving towards or opposite to the field direction. The material is act as a conduction. ஓகேவா? சோ அந்த மெட்டீரியல் வந்து கரண்ட் கண்டக்ஷன் ப்ரொடியூஸ் பண்ணும். ஓகே. சோ இப்போ நம்ம என்ன ஃபைண்ட் அவுட் பண்ண போறோம்னா without applying the field total number of electrons. The total number of electrons எவ்வளோ? அப்ப the total number of electrons is nothing but the total number of electrons in solid. This is our considered solid material. In solid is represented by capital N. Okay, so the total number of electrons present in the solid material is represented by N. So the total number of electrons na enna podlam? Number of electrons, that particular area, that length of the material. Okay, so you have to write capital N is equal to number of the electron, that area into length of the material. So that length of the material. Understood? This first step. First step understood, Amma? Next. So this is your first equation. This one is your first equation. It's not in your book. Take notes. Everyone take notes. It's not in your book. Book la irundhalum notes eludano, but take notes. But in this step, it's not in your book. Okay. So the total number of electrons in solid material is equal to small n A into N. Now we will write the term of the total charge. Total charge in solid material. Total charge in solid material. Total charge in solid material is represented by Q. Okay. The total charge in solid material is equal to total number of electron into charge of one electron. So what you write here? Total number of electron into charge of one electron. One electron. Charge of one electron. Okay. The total charge in solid is equal to total number of electrons into charge of one electron. So you have to write Q is equal to N into charge of one electron is minus E. Okay, so because electron is negative now, so you have to put it minus. Some of the minus, minus 4 less, but in your book it's in minus only. So you follow like this. Okay. So Q is equal to N into minus E. Okay, ma? Up to this clear? Is there any doubt now? Girls from girls side? Is there any doubts? Doubts come. Okay. So now this is your second equation. Substitute. Now substitute equation 2 in equation 1 in equation 2. Equation 1 enga substitute pandrom, equation 2 la substitute pandrom. So you have write Q is equal to N is what here? N enadhu? N A L into and then E minus E. So this is the third equation. This one is the third equation. Okay. So now we will write the term of the next step. Okay. So now when we apply some electrical field. Now when we apply some electrical field, all the electrons are moving towards the field directions. So that's the reason that the electrons is nothing but it is moving in our consider particular directions. Consider particular directions. Electrons is moving in our consider particular directions. So that's the reason here the drift velocity is produced. That's the reason here the drift velocity is produced here, and also listen, and also here the current conduction is also produced. Okay. So now we will write the term of the current in the solid material. The current in the solid. So you have to write current in solid. The current in the solid material I is equal to charge of the electron in our considered solid material divided by time taken for the motion of the charges. Time taken for the motion of the charges. So you have to write the term of the current in our considered solid material is equal to charge of the materials in a what now? It's not tau, it's T. It's அது tau கிடையாது. உங்க bookல வந்து அது T தான் வந்து tau மாதிரி போட்டுருக்காங்க. That's why I write here T. ஓகேவா? It's not tau. It's T. ஓகேவா? உங்க bookலயுமே அது வந்து டைம் தான் மென்ஷன் பண்ணிருக்காங்க. ஓகேவா? It's not tau, it's T. Okay? So here I is equal to current present in the solid is equal to charge in our considered solid material divided by per unit time taken for the motion of the charges. Okay, so in our next step, I is equal to QR. So this is the fourth equation. This one is what is the fourth equation. Now substitute equation 4 in, not equation 4, equation 3 in equation 4. Substitute equation 3 in equation 4 here. Okay. So what you write here? First I is equal to, and then what is Q value? N A L into E divided by small d. Understood in this step? Any doubt? So now, when the current is produced in our considered solid material, so it has some current density. Okay. So for the formula for the current density is I divided by A. Okay. Because the current density is nothing but it is the definition enna. So it's nothing but it is the amount of flowing through the current passing through the material per unit area. Per unit area is called as the current density. So the current density is represented by, listen, the current density J is equal to the amount of flow of current passing through the material per unit area. Listen, per unit area is called as the current density. I divided by A. It's studying plus 2 now. J is equal to I divided by A. So this is the fourth term. This one is the fifth equation. And this one is the sixth equation. Now substitute equation 5 in equation 6. Now substitute equation 5 in equation 6 here. So what is right here? J is equal to, which one is the fifth equation? I. So N into E divided by small d divided by A here. Okay, ma. So what is in our next step? J is equal to, here also one is there. So N A L minus E divided by small d into 1 divided by A here. So here A cancel pannama. Shall we cancel A? So A is cancelled. And now listen now. So here drift velocity is represented by L divided by small d. So this is represented by drift velocity. Okay. So the motion of the electrons now. Okay, so the drift average velocity acquired by the free electrons in a particular direction. Electrons is getting some motion now. Electrons is getting motion on that length per unit time we will call as the drift velocity. Okay, so now substitute this drift velocity term. So L by T is L by T is what here? BD. So now write J is equal to N into BD into minus E. So this is the equation for seventh equation. Understood here? Up to this here, is there any doubt? Is there any doubts here? Okay, good. So now come to the Ohm's law in this current density. Ohm's law in current density. I is equal to Ohm's law in current density. So you have right here current density in Ohm's law. Current density in Ohm's law. What is the Ohm's law here? I is equal to P by R. What is the resistance value? R is equal to, so this is the equation, 7th equation, and then resistance value is equal to rho L divided by A here. Resistance value is what here? Rho L divided by A here. Okay, so this one is the 9th equation. So resistance is nothing but in our considered material and resistivity called as the resistance. Okay. So the opposition of the booklet opposition offered by the solid material in our considered motion of the electrons. Okay, so the our considered material as resistance. So the resistance is directly proportional to the length and the resistivity, and inversely proportional to the area of the material. Okay, so it's the formula only. So now substitute. Now substitute equation 9 in equation 8. Okay. So what you get? I is equal to B divided by and rho L divided by A. So what you write here? I is equal to what here now? I is equal to VA divided by rho L. Is equal to what is that? VA divided by rho L. Understood? Up to this step here. Any doubt in this step? Any doubts now? Okay, so this one is the 10th equation. This one is what here? 10th equation. Listen. So now we'll take it as the current density. What is the formula for the current density? J is equal to I divided by K. No? So take that equation. Now substitute equation 10 in equation 6. Substitute equation 10 in equation 6 la substitute பண்ணுங்க. So J is equal to what here? J is equal to V divided by so J is equal to V A divided by rho L and divided by A. So A divided by 1. Okay. So in our next step, J is equal to V A divided by rho L into 1 divided by A here. So what will get here? A cancel here, and then finally what will get? J is equal to V divided by rho L. So what is the formula for the conductivity? What is the formula for the conductivity? 1 divided by conductivity is what is represented by sigma. No, shall we write sigma is equal to 1 divided by rho? 1 divided by rho போடலாமா? Because it's inversely proportional to the resistivity. Okay va? Conductivity is inversely proportional to resistivity, and then applied electrical field is equal to voltage per unit length. Applied electrical field is equal to voltage per unit length. So I will write here E is equal to V by L. So substitute these two equations in our previous equation. So what will get here? This one is 10th and 11th equation. This one substitute here. V by L is what here? E, and 1 by rho is what here? Sigma. So J is equal to sigma E. So this is the 12th equation. So this equation represents the relation between of the current density and the applied field. Understood? Any doubt in this step? Any doubt? And also here, this is the term in our next step. Still not completed. So in our next term, now take equation 7th. So now equating equation 7 and equation 12. Equating equation 7 and equation 12. So what you write here? 12th equation is equal to 7th equation. Okay, 12th equation is equal to 7th equation. Last row by squaring here. So here now we write the 12th equation is what here? This one. So sigma E is equal to, and then 7th equation is what here? N Vd into E. So N Vd into E. Okay. So now what we will find out here? Here now conductivity we will find out now. So now write here E is equal to, not E, sigma is equal to N Vd into E divided by E. Now we Vd. Okay, Vd divided by E is what here? Anyone tell me what? Mobility. So substitute. So Vd is equal. Final segment I write here. So sigma is equal to N into mu into minus E. So this equation is the relation between of the conductivity and the mobility term here. Okay, wow. So yeah, sigma is equal to N into mu into minus E. Okay, wow. So this is the expression for the electrical conductivity in terms of the mobility. Okay, wow. Mobility base money we will discuss here. Okay. So any doubt in this step? Any doubts?